Hey guys, this is Carrie, and in this lesson so far, we've been talking a lot about fractional exponents. So let's continue that conversation. All right, so here we go. We're going to start with the big idea. So what we've been working towards is this conclusion. Basically, if you have x to any fraction here, let's say 3/5 power, what it means is the number on top will tell you what power we're going to be raised to, and the number on bottom will tell us what root we're going to have. So it turns out there's an easy way to remember this, but just writing down the answer here, it's going to be the 5th root, because the root is on the bottom, and then x to the 3rd power. So this and this mean the exact same thing, which is totally awesome, because we know how to work with this, which means we know how to work with this. So that easy way to remember things, basically. Let's say we were going to do another example. Let's say we had x to the 7, let's say we had x to the 7/5. Oh, well, I'd already used fifths. Let's say x to the 7/4. Here we go, some new numbers. All right, well, we know that like a plant, the root is going to be on the bottom, or the roots are going to be on the bottom. And then maybe if we're powerful, we'll be on top. We'll be the ones who win if we're powerful. So power's on top. Just happens that these words are nice for describing this. So we have the x to the 7th power, because that was the number on top. And power means that we're on top or winning. And then 4th root here, it would be 4th root, because the root for the bottom of the plant is on the bottom of the fraction here. All right. So let's do some of these practice problems, or these lesson problems, and then you can do some practice problems. So to actually, kind of working out of order here, I apologize, but this one seems like the one I gravitate towards. I always prefer variables in comparison to things with numbers here. So which of the following is equivalent to x to the 3/5? Okay, well we just talked about this. Power on top, root on the bottom. So we have the 5th root of x to the 3rd power. Choice 3. Sweet. All right, now how does this come up for numbers? Well, numbers always make things a little bit more complicated, unfortunately, but I think we'll still be able to figure these out. So here we go. These ones, 8 to the 1/3 power. Okay, well, 1 will be the power, and then we'll have the cubed root of 8. Oh, okay, so this is just going to be 8 to the 1st power is just 8 times itself, 8 just by itself, so that's just cubed root of 8. And hey, we know how to do this. What number times itself, 3 times, gives us 8? This is a question we've answered a couple of times. This has to be 2. And if you actually put this in on your calculator, maybe we'll pause for a second and do that. 8 to the 1/3 power, popping over to Desmos. We've got so many calculations here. All right, here we go. 8. And then we do to the AB power. So these are just placeholders, basically. And then I have to put parentheses here so I can put that whole fraction in the exponent. Ooh. And I've got to use some arrow keys here to get my parentheses right. Yeah, it is 2. Desmos agrees. Sweet. All right, -64 to the 1/3 power. Okay, this is going to be -64 to the 1st power, cubed root. Anything to the 1st power is just itself. So now we're looking for the cubed root of -64. Oh man, all right, well, cube root of a negative. We know that's just going to make our whole answer negative, so that's going to be my first step, is to pop that negative out. And then, all right, there's a couple ways to think about this one. We could break 64 down. You know what? I'm gonna skip C. All right, you can skip C also. I need the room here. Sorry. 64 breaks down into 32 and 2, 16 and 2, 8 and 2, 4 and 2. Oh my God, too many 2's. So here we go. Negative cubed root of 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Yeah, cool. All right, awesome. So it's a cubed root. So groups of 3 here. 2 groups of 3. 1 escapes from each group. The rest die. So 2 times 2 outside is going to be negative, because of the negative sign here, -4. And then nobody's left in jail, so we don't write the jail. And we're done. Make sure when you're typing these into your calculator to check these. you would actually have to put the whole of negative 64 in parentheses. Oh my gosh. Let's see if it will let me do this. Okay, cool. The whole of negative 64 in parentheses all to the 1/3 power. Because you want to include that negative sign inside of the power. All right, determine the value of each of the following. All right, 25 to the 3/2. Oh man, okay, things are getting worse for us here. So 25 to the 3/2. Okay, so 25 to the 3rd power, and then the second root. And the second root should look a little funky to you, because we don't often write the 2, right? When things are escaping in groups of 2, that's just the normal square root. So basically, a normal square root means escaping in groups of 2, so this is the same thing as that. So usually we'll write this like this. Now, if you try to do this on your calculator, 25 cubed is a huge number. I do not want to take the square root of that, and I don't have to. I'm lucky. There's a nice property of these square roots where you can actually rewrite this as, okay, do the radical first, and then cube it. So you can actually switch the order of the radical and the exponent here. All right, well, square root of 25 is 5. And then 5 cubed is going to be 5 times 5 times 5 times 5. That's going to be 125. Sweet. All right, here we go. This one right here, 64 to the 2/3. All right, well, that's going to be 64 to the 2nd power, cubed root, because cubed root is on the bottom. All right, again, though, if I do 64 squared, I'm going to be so miserable right now, because check it out. 64 squared is a huge number. So instead, we're going to switch the order, because we can switch the order of roots and powers. So we'll do cubed root of 64, and then we'll square the answer. Now, I actually broke down 64 up here, which is really nice for me, so I don't have to redo that. I'm going to take the cubed root of 2 times 2 times 2 times 2 too many 2's, and then square it. When we do the cubed root of this, they escape in groups of 3, so we get 1 from each of these escapes, which leaves us with 2 times 2, 4, nobody left in jail. And then we have this squared out here, so we have to do that squared here. And that leaves us with 4 squared, 4 times 4, 16. All right, well, one of the nice things about these fractional exponent problems with numbers, there's not many nice things about them. It takes a little bit of work to do, but they're easy to check. You can just pop over here, and let's do 64 to the 2/3 power. 64 to the parentheses here, 2 divided by 3, so that the whole thing is in the exponent. Oh my gosh. Right arrow key, close the parentheses, and then we get 16. Sweet. So this is actually awesome. All right, guys, the rest of the problems are practice problems for you. Good luck with them.